In this video, we will be looking at 2.5 Part 2. We're dealing with solving inequalities. Now we're talking about quadratics and rationals. Again, inequalities are one of these symbols. To talk about this section, we're going to go straight into an example. Okay, let's take an example of this quadratic inequality. Example number 1. Let's say we have x squared minus x is greater than 6. All right, it's a quadratic because it has this squared term here. Step 1, we're going to determine the zeros of the associated quadratic equation. Okay, find the zeros of the associated quadratic equation. What I'm saying is we're going to change this greater than to an equal to. All right, and we are going to find what the zeros are. That is, we're going to solve this equation. All right, and to solve this equation, we'll use the zero product property. We learned all of those properties or all those methods for solving quadratics. This zero product property involves factoring. Okay, so when we solve this with factoring, the first thing we did was set it equal to 0. We subtract 6 on both sides. So I have x squared minus x minus 6 is equal to 0. All right. Now, again, I've chosen the zero product property. You're not adding this to your notes. You're just thinking about it. Solve quadratics. We learned several methods for solving quadratics. This is one, the factoring method, zero product property. Okay. One method we learned was the quadratic formula. One method we learned was completing the square. Okay, so you can use any of these methods to find the zeros of this associated function here, the solutions of it. So I have x squared minus x minus 6 is equal to 0. I'm going to now factor this equation. I could use my big X method. I'm just going to go right to it here. X squared is x times x. Since we have a minus in this second position, I know 1 plus 1 minus. I know I need to multiply to give 6. That's going to be 3 and 2, minus 3 and plus 2. X times x is x squared. Positive 2x minus 3x is a minus 1x. Positive 2 times negative 3 is a negative 6. All right, now I can set each one of these factors equal to 0. X plus 2 equals 0, and separately x minus 3 equals 0. Here we'll subtract 2 from both sides and get that x is negative 2. And then here we'll add 3 on both sides, and we will get that x is positive 3. All right, these values are going to be very important to us. This value x negative 2, this value x 3. Okay. Step 2. Draw a number line. And focus on step 1 results. Okay. So the numbers that came out right here, these are going to be the important numbers on my number line. I'm drawing a number line. All right, I'm not worried about 0. I'm worried about negative 2 and 3. Here is negative 2. Here is positive 3. Okay, these are the key numbers. Step 3. Return to inequality. All right, so I've previously went from writing this as an inequality to an equation so I could find these zeros. Now I'm going to go back. I'm going to go back to my inequality. X squared minus x is greater than 6. X squared minus x is greater than 6. I'm now going to set this inequality greater than or less than 0, whatever it may be. Return to inequality, setting to 0, meaning I'm going to get a 0 on this side of the inequality. So I'm going to subtract 6 on both sides. Alright, on this side I can't combine. I have x squared minus x minus 6. That's that same quadratic expression as before. Alright, so essentially we have the same, it's an inequality where previously we had an equality. Alright, we know this side is greater than 0. To say that this side is greater than 0 is to say that this side is going to be positive, because positive numbers are greater than 0. To get a positive number, we know we need to multiply positives together or negatives together. They couldn't be opposite signed. So now I'm going to employ my factoring one more time. We've already factored this. And this is why the factoring method is the best method to use for this particular process, because you're going to need to examine these factors. All right. I know I want these two things multiplied together to be greater than 0. So I'm going to consider what are the signs of these things. Well, it's important how they behave around these numbers. On the top of my number line, I'm going to consider how does x plus 2 behave. Up here I'm looking at x plus 2. Okay. On the bottom of my number line, and it doesn't matter which one you put on the top or the bottom, and you can do this with more than 2 factors as well, but we're just looking at 2 for right now. I'm going to look at how x minus 3 behaves. Alright, so now I'm on the bottom. I want to consider how x minus 3 behaves when I'm less than negative 2. If I substitute a number less than negative 2, like negative 3, 4, 5, well, negative 2, 3, 4, 5 minus 3 is going to give me a negative number. So over here, this thing is going to be negative. How does it behave from negative 2 to 3? Well, at negative 1, it would be negative. At 2, 2 minus 3 would be negative. Everything all the way up to 3, it's going to be negative. So that behaves, this factor is going to be negative from negative 2 to 3. How does it behave above 3? Well, if you put a number above 3 in here, like 4, 5, or 6, any of those minus 3 is positive. So here we see how x minus 3 behaves. In this section of the number line, it's negative. In this section, it's negative, and above here, it's positive. Let's consider how x plus 2 behaves. Alright, if we're less than negative 2, substituting in numbers less than negative 2, like negative 3 plus 2 would be a negative 1, it's going to be negative. If I'm between negative 2 and 3, that's like negative 1, 0, 1, 2. Well, here you're going to see it's going to be positive, because negative 1 plus 2 is a positive 1. 2 plus 2 would be 4. So in this region, it's positive. In the greater than 3 region, substituting numbers like 3, 4, 5, and so forth, you'll see that that's positive. So that's how it behaves there. All right. So now we see we have the product of, down here, 2 negatives. Well, 2 negatives makes a positive. So that product is going to be greater than 0. So this area down here is good for us. I'm going to highlight that. Since we have our signs being the same, negative times negative, that's a positive. This area is good for us. In here we have a negative times a positive. Well, that yields a negative, so this doesn't work. But up top we have a positive and a positive, so this area is good for us as well. Alright, thus our solution set, we must be greater than 0. We can't be equal to 0, so at these points it's going to be equal to 0. They're no good to us. Our solution set graphically looks like this. We're okay above 3. That's an empty point, not colored in. We're okay above 3. We're okay below negative 2. Again, empty point. Now, less than negative 2, we're good there. The area between negative 2 and 3, it is not in my solution set. So, how do we write this? We write it in this fashion. We can say that we are from negative infinity to negative 2. We are from negative infinity to negative 2. And we can't be negative 2, so it gets an empty. And then we use this symbol here, union. It means or. Okay, this one or this other one works. And then we are from 3 to positive infinity. From 3 to positive infinity. Okay, this is one way to write our set. Another way to write the set is to say that x can be less than negative 2 or x is greater than 3. These are two ways to write that. All right, what if we have a division? Well, same thing with a division. If we have some polynomial, this concludes this, and by division we're talking about a rational function. A rational function is some function of the form p over q, where q is not equal to 0. We have some kind of division. So if I have p over q is less than 0, all I want to make sure is that one of these is positive and one is negative, or vice versa. So it's going to happen in a similar type situation. Here I would set p positive and p positive and q negative, or p negative and q positive. So we see both scenarios. If we are going to be greater than 0, we need them to be same signed. If we're going to be less than 0, we need them to be opposite signed. That concludes this video.